Hello and welcome to Privilege Escalation using SeDebugPrivilege, the 27th video as part of our Red Team Fundamentals mini-series. Throughout this mini-series, most of our discussion, the tactics and techniques we carried out, has been from the perspective of a low-privileged user account, so that is a standard Windows user. Nevertheless, from this context, we still managed to enumerate the system and even establish some means of persistence. However, there will come a time when, to progress further into the network, we will need to perform some actions that require elevated privileges. For example, tasks such as dumping the system's memory to obtain cache credentials cannot be carried out by any standard user, as that would constitute a significant security vulnerability. Therefore, operations of this nature can only be performed by privileged accounts. Now, since such attacks and similar ones can reveal valuable information, we need a way to overcome this limitation. This process is known as privilege escalation, the anatomy of which, along with several techniques, we will discuss in this and the following videos. As always, everything we teach in this video is purely for educational purposes. We accept no responsibility for your actions. So, privilege escalation at a high level consists of techniques used to obtain elevated permissions on a system or network. Essentially, it is the vertical process of elevating access from a low privileged user account, which is typically the initial level of access we obtain to a high privileged user account, enabling us to leverage the account's permissions to perform any elevated activity on the target system, such as our earlier example of dumping the system's memory. There are many ways to achieve this, however, the primary objective is to obtain an account that is either a member of the local administrators group, or better yet, direct access to the NT authority system account, which possesses the highest level of privilege on the local system. Now, if you're familiar with Linux systems, the system account is equivalent of root. Therefore, just as you can perform any action with root on Linux, you can do the same with the system account on Windows. Now, as mentioned earlier, there are numerous ways to escalate from a low privileged user account to a high privileged one. And one such method is through Windows native privileges. Now, a privilege is essentially a granted right to perform a specific task. And such tasks could include, say, loading device drivers, backing up files and folders, or any other action that requires explicit permission from the Windows system. Now, we can actually view some of these privileges by going into the local security policy editor, and then under security settings, local policies, user rights assignment, you'll see all of the privileges available in Windows. So for example, you've got some privileges here to allow a user or a user of a group to log into the system via remote desktop services or RDP. Then you've got some privileges like backing up files and directories, loading and unloading device drivers. And then each of these privileges can be assigned either to a specific group or a specific user. Now, one of these privileges is called Debug Programs, or its abbreviation SeDebugPrivilege, which grants us the ability to debug memory of local Windows processes. Now, typically this privilege is assigned to developers who require the ability to debug system processes. However, because Windows does not permit granular control over its process attributes, this privilege allows for system-wide memory access, enabling us to debug programs owned by other users, and even those owned by the local system account. Therefore, if we possess this privilege, we have the authority to access the memory contents of such processes and even manipulate them to inject custom functionality. Now, this privilege can be exploited in numerous different ways. For now, let's take a look at how we can migrate into an elevated process to inject sliver implant shellcode, and then later we will take a look at how we can dump cached credentials. Now, before we can abuse the SeDebug privilege, we have to make sure that this privilege is enabled in the first place. And to do this in Sliver, we can use the getprivs command. Now, once executed, you'll see a listing of all of the available privileges. And as can be observed, one of those privileges is indeed SeDebug. Now, you'll also notice that in some cases, there will be certain privileges that are disabled by default. Now, this happens because some privileges are only used when required. So for example, the SE shutdown privilege here would only be used when the system is being shut down. However, some privileges can be automatically enabled whenever the process is running in a high integrity level. Now, mainly there are 3 process integrity levels you can have within Windows. You've got low, medium, and high. Now, by default, typically the integrity level will be medium, and the integrity level of high is only available when the UAC prompt is confirmed. Now, we'll get into the UAC and some techniques in which we can bypass it to obtain a high integrity level. But just note now that in order to use the SeDebug privilege, a high integrity level is necessary. And just to kind of reinforce the concept, you'll see here that whenever running in the medium process integrity level, the privilege does not even appear. Now, in order to directly obtain a sliver implant session, what we can do is inject sliver implant shellcode into a process that is running as the NC authority system account. And because the process is running under that account, any injected shellcode into it will execute in its context. And this is precisely what the getsystem command performs. Now, in Windows, there are several different processes that run in the context of the system account by default. And one of those processes is the print spooler service, which operates within the spoolsv.exe process. Now, in the case that we want to inject into a different process, perhaps one running as a different domain user, or a different process running under the context of the system account other than spoolsv, we can specify the name of that process using the p switch. Now, in our case, we will just inject into the default process that getsystem specifies. And then if the command is successful, you'll see that sliver reports that a new system session should pop soon. And then shortly after, we receive our new session. And then to confirm that indeed we are now running as the NC authority system user, we can use the who am I command. And as you can see here now that our context is indeed of the system account. Now, whilst obtaining the highest level of privileges on a system is valuable, it is important to note that these privileges apply only to that local system. As we progress to lateral movement, we will typically be unable to reuse those privileges on other networked systems. Therefore, in addition to injecting into process memory, we can also extract the contents of process memory. And there's no other better process than lsass.exe. Now, in Windows, the local security authority, often abbreviated as LSA, is the entity that manages and oversees authority on a local system. And its main purpose is to facilitate user authentication. So whenever a user logs into the system, the WinLogon service collects the supplied credentials and then passes them to the LSA. The LSA then verifies the credentials and determines whether to authenticate the user. Now, to perform this authentication, the LSA uses what is known as an authentication package, of which there are several in Windows. 2 of the most commonly used ones you will come across are MSV, which authenticates local users, and Kerberos, which authenticates users across an Active Directory network. There are others like CredSSP and Cloud AP, but those are less frequently encountered. Now, the important point is that whenever these authentication packages validate credentials, some of them, like MSV, cache them in memory for reuse whenever necessary without having to prompt the user again. And these are cached in the lsass.exe process. And because the SeDebug privilege provides us with access to debug processes, or more precisely read in this case, we can obtain its memory contents, parse them, and extract the encrypted values. Of course, the LSA is far more complex than this, but at a high level, this is how it functions. The key takeaway here is that the lsass.exe process stores credentials in its memory. So with that understanding, let's take a look at how this can be applied in practice. Now, just before we get into dumping the contents of the lsass.exe process, it is important to acknowledge that in Windows, the LSA is protected by default. And this protection mechanism is made available through what is known as Protected Process Light, or PPL. Now, at a very high level, what the PPL ensures is that processes such as lsass.exe are not tampered with. That is, it ensures that any process that it protects and its contents cannot just be arbitrarily opened. Now, for the purposes of this video, I have disabled its setting. However, it is enabled by default. And in later videos, we will discuss how to bypass PPL. However, compared to this video, it is an entirely different beast. Now, when dumping the contents of processes such as lsass.exe, we have to create that process's equivalent minidump. And the easiest way to describe a minidump is that it is a snapshot of the state of a given process at a given point in time. And that snapshot will contain its memory contents to which we can then pass. Now, to create this minidump in Sliver, we can use the procdump command, which requires the PID of the process we are creating the minidump of. So we will have to use the P switch to specify the PID of the given process, and then optionally where we will be saving the minidump. And just keep in mind that the minidump will be saved locally on your machine and not the target machine. Okay, so having understood how this command works, I will specify the PID of lsass.exe and then save it under the name of lsass.dump. And the dump extension here just signifies that it is a mini dump, and it's not necessary. You can just save it under whatever extension you want. Okay, so let's execute this. And just note that it might take some time to perform. So in the case that it takes longer than a minute, you can specify a timeout value that is greater than 1. Okay, and once Sliver is done dumping the contents of lsass.exe, you'll see that it reports that it has been successful, and then to confirm, we can just list its contents locally. And indeed, you can see that the file is there. Now, besides just using procdump, which is only available on Sliver, by using the LOLBAS repository, you can find several additional tools that are available for the same purpose. For example, we can use the comsvcs.dll, and the way it works is by using the minidump write dump function. And actually, this is the way in which Sliver's procdump command works. So it takes the PID of the process it is creating the minidump of, and then writes that minidump to a file. So if we copy this command here, and then within our Sliver interface, use the execute command to execute this, make sure to wrap the path to comsvcs.dll within single quotes, and then make sure to update the PID of lsass.exe to 784. And then if we execute this command, you'll see that no output is presented. But if we use ls with dump.bin, indeed, you will see that it is present. It just appears that the function minidump of the comsvcs.dll does not produce any output. But as you can see here, similarly to how we used the procdump command, we can also use native Windows tools to create minidumps of given processes. Now, with the minidump of the lsass.exe process, if we tried to use something like cat to view its contents, you'll see here that we get just gibberish output. And if we try to, make sense of any of this, you'll see that it is just simply impossible. Now, fortunately for us, the minidump file holds a specific structure, and in order to parse its contents, we need a parser. And one of those parsers that we can set up on Kali is called pypykatz. And as you can see in its description here, it claims to be an implementation of Mimikatz in pure Python. Now, this tool supports numerous different capabilities and features, but in our case, we will be using it to process a minidump file. I recommend that after this video, you explore this tool in greater detail. Okay, so let's clone the repository. And then within the repository, we are going to create a new virtual environment. And then that virtual environment will need to be activated. Perfect, so now we have an isolated Python environment. So let's use pip3 to install all of its required dependencies. And then as output demonstrates, it successfully managed to build a tool. And to confirm that it's all working, we can use the pypykatz command with the version argument. And as you can see here, the version is printed. Now to process the minidump, pypykatz supports various different modules as arguments. And the module we will be using is LSA. And then as part of that module, to specify the file we are specifying is a minidump, we will need to specify the minidump argument, including the path to its contents. Okay, so specify the argument of minidump, and then the file itself is called lsass.dump. And if we execute this, you'll see that we get a listing of all of the extracted credentials from the lsass.exe process. Now, every credential as part of this process is stored within its relevant logon session. And a logon session is generated for a specific user whenever that user logs in. So you can see here we have a logon session for vvolkov. We also have their domain, their SID value, and then that logon session's unique ID. Now, remember, I said whenever LSA authenticates a user, it uses a specific authentication package to do so. So as you can see here, the MSV authentication package holds the NT hash of the user account. And I believe the NT hash is hashed using the MD4 algorithm. So we could take this value and attempt to brute force it offline. We've also got the Kerberos authentication package, and this package holds the Kerberos encryption keys, which are also derived from the user's password and are used to encrypt the pre-authentication message whenever requesting a TGT. You can also find some storage mechanisms like Credman and its plaintext passwords, and we get into Credman and DP API in our course, which we won't get into in this video. However, the main principle here is that we can obtain every logon session and its contents at the time for when the minidump was generated, the minidump of the lsass.exe process in this case. So with these values, we could potentially use them to move laterally within a domain by passing the hash, or in the case of Kerberos, AES keys by using pass the key attacks, and the list goes on. Now, if we wanted to, we could also use Mimikatz directly on the target system. And to obtain the memory contents of the LSAS process using Mimikatz, we can use the secure LSA module. Now, as we scroll down here, you'll see a listing of all of its supported commands. For example, the secure LSA logon passwords command dumps all provider available information. However, if we wanted to, we could also extract specific information. For example, the ekeys command extracts the Kerberos encryption keys. The MSV command extracts MSV applicable credentials, and the list goes on here. So I suggest that you take a look through all of its supported capabilities. Now, to obtain output, as we saw with pypykatz, we can use the logon passwords command. And remember, this obtains all of the credentials of the supported authentication packages. And before we do so, whenever running Mimikatz, we must first ensure that the debug privilege is enabled for its process, as otherwise the command may fail. So this highlighted command that you're seeing here just essentially enables the SeDebug privilege in the case that the process launches with it disabled. Okay, so let's execute this command, and going up here, you'll see that we get much of the same information that we observed with pypykatz. And under the hood, it performs pretty much the same functionality as we observed when creating minidumps. However, this just gives us the advantage of being able to execute Mimikatz within an existing session without having to obviously create a minidump first and then pass it through something like pypykatz. However, just be aware that obviously we are loading Mimikatz into the target system, to which an EDR can very quickly pick up. So from an OPSEC perspective, the first method is far superior than using Mimikatz directly. And that concludes our exploration of privilege escalation using the SeDebug privilege. I hope you found this video informative. In the next video, we will take a look at another privilege called SeImpersonate. This privilege is often assigned to service accounts, which are also commonly acquired during assessments. In the meantime, feel free to join our Discord server to stay up to date with us, explore our courses, soon to be released labs and one of the finest red teaming courses available. I've left a link to our group in the description below. Until then, stay safe and I will see you in the next one.